Good day, learners. We are doing Newton's second law and the application of Newton's second law. Before we start, we need to know the symbols that we are going to use. So we have N for the normal force. We have W, small letter W for the weight. We have small letter F for the frictional force. We have capital letter T for tension. Then for force applied, we just write F. Okay, so for that, so the normal force is defined as a force or a component of a force which the surface exerts on an object in contact with it and act the surface. So we also have the frictional force, which is defined as the force that opposes the motion of an object and acts parallel to the surface. So we are going to draw the free body diagrams first because it is very important to draw a free body diagram. So the first thing that we are going to do, we will have a free body diagram and the net force, how we deal with the net force. Okay, so I have this object as 2 kg block. So up is a free body diagram versus free body force diagram, free body diagram. So I have the net force, how to calculate. So net force on how to calculate. So the first thing, there is a force that is applied there, 10 newtons to the right. So when you draw a free body diagram, you have to define every force. So here in this object, there is a surface, and the surface is rough. We have the normal force. Normal force is the force that acts perpendicular to the surface. The surface is rough. We have, let's say, the motion is in this direction. Motion is in that direction. Therefore, the friction will oppose the motion as its definition is such. Then we also have a weight. Every object has a weight, and the weight must always be vertical. It's a vertical force. Normal force must always be perpendicular. Weight is vertical. So the free body diagram will be like this. So we have a force that is applied. We said it must be a capital letter F. We have a normal force. Then we have a frictional force, small letter F. Then we have a weight. That is the free body diagram. Now, when you are about to calculate, you must have another free body diagram for calculations. Ungayiphazamisi le ibuziweyo. So this is for calculations. Oh, it's a capital letter F ne corner up. Then we have a small letter F, round like S. Then we have weight there, small letter W. So this one is for calculations. So you can do whatever you want to do here. So the net force from the formula, net force is equal to MA. Okay, net force is equal to MA. So ithi ke ngoku le nto sizawufokhasa kwi-forces as horizontal only, or sifocus kwi-forces that are vertical only. Now the focus is here. Friction must always be negative, therefore this one now is positive. Okay, but the friction opposes the motion, therefore it must be negative. Then this one must be positive. So force applied is positive minus frictional force, which is equal to MA. Now we are going to use this one in this case, therefore you just substitute it there. Okay, now let's look at another type of question. Oh, I didn't finish. Let's also check the normal force. If we talk about the normal force, we have a vertical forces. Okay, let's just take up as positive. Therefore, this one is negative. Therefore, F net is equal to MA. Sorry for that. F net is equal to MA. Okay. So for the normal force and weight, the normal force is positive minus weight, which is equal to MA. But we know that the normal force and the weight in this case are equal in the opposite direction. So it is very simple. If forces that are going upwards must be equal to the forces that are going downwards, because the forces are balanced, F net is equal to 0, which means there is 0 here. Now if you transpose weight wecala izofika ibe positive, i-forces ezinyukayo zilingane forces ezehlayo. Always when we are calculating the normal force. Let's look at this example. So in this example, the force that is applied now is at an angle 2 kg. Is at an angle theta. Theta is 30 degrees in this case. So the force is 10 newtons. So the free body diagram will only change 10 newtons. So we have a what? A normal force, then a frictional force. We also have the weight. Okay, so the free body diagram will have the force that is applied, slanted force. So sibe ne normal force, sibe no Fk, but F for now, then sibe ne weight. That is the free body diagram. Okay, so for calculations, you draw another free body diagram. Lena yebuziweyo, for example. So we have lena again with calculations. There is a normal force again. There is that force that is applied. There is a frictional force, small letter f. Then we have a what? A weight. But this one is slanted, is at an angle, which means we have the components for yona. So we have Fy component, Fy, and we have Fx. Sorry for that. So we have Fx. Okay, say original share components because zobala ke ngoku. Okay, now when you calculate, you must make sure that you focus on forces that are collinear. So ezi is horizontal, therefore we are going to use them. So F net is equal to MA. This is Newton's second law. F net is equal to MA. So friction must always be negative, which means this one now is positive. Therefore, Fx minus a frictional force will be equal to MA in this case. Therefore, you will calculate whatever that is asked on the horizontal forces. Once you want an angle, you must have the components as we did here. Then if we look at the normal force, remember I said the upward forces must be equal to the downward forces. So I'll just say the normal force plus Fy is equal to ezizoyi-2 ziyenyuka is equal to ehlala is equal to the weight, because kaloku sithi the forces are balanced, which means F net is equal to 0 newtons. When the forces are balanced, you just write this one, you are correct. Okay, and then we're done with this case. Now let's go to another free body diagram versus calculating the net force. Sorry. All right, so now the focus is on an inclined plane. Focus is on an inclined plane. The object is moving up an incline. 30 degrees. There is an angle again. I said when you see the angle, there must be the components. So we have the object that is here, 2 kgs, and is pulled up by 10 newtons. 10 newtons. And the motion is also up. Motion of the object is directed. Motion is directed up. So let's draw the free body diagram. Remember, when you draw a normal force, it is perpendicular to the surface. The force that is perpendicular to the surface, and the object must be in contact to that surface. That is the normal force. Then the friction opposes the motion. The motion is going up. The friction must go down an incline. That is a friction. So sibe no Fg, that is a weight. We have a weight. So the free body diagram, yalena izoba ne force applied, capital letter F. Then sibe ne normal force. Then sibe no Fk, that is kinetic friction, but asimbhali okay free body diagram esizoyibala. Then sibe ne weight, Fg, but asimbhali Fg. Then sibe ne free body diagram yokubala ke ngoku. So a free body diagram yokubala yona will be like this. So we have these forces, that is force applied, no A, then sibe ne normal force, then sibe no Fk, no K, then sibe no Fg. Now that is incline, you must know that there are components of the weight. Okay, there are components of the weight. So we have the weight that is perpendicular to the surface, weight perpendicular. We have a weight that is parallel to the surface, weight parallel. So the weight is calculated, parallel is calculated by mg sine theta. Abe yena weight or perpendicular simbala ngo mg cos theta. Okay, so ithi ke ngoku le nto nalapha we do the same thing. Ii-forces ezicollinear, so sinezi forces, they are on the same straight line. Zenza u-net force wethu. So F net is equal to ma. So the F net for this one, F net for this one, so F net is equal to ma, F net is equal to ma. But if you can look here on the free body diagram, we have the friction W parallel and F applied. The friction must always be negative, therefore this one is also negative, therefore this one is positive, because opposer A is also 2, therefore positive. So the net force now will be a positive force applied minus frictional force minus W parallel, that is equal to ma now. Utsho ukwazi ubala. Now if we look at the normal force is collinear with this one. Okay, therefore the normal force is equal to W perpendicular, that is the normal force. So then we're done with the free body diagrams. Then some cases will need a tension, we'll have the tension force. I will just do one. So we have this one is 2 kg, for example, is pulled by a 3 kg, for example. This one is 3 kg, which was pulled by 10 newtons. Okay, now we have to draw a free body diagram in this case. So there is a surface and the surface is rough and the object is in contact with this surface. What we are going to do, we will start with this one. Let's name this one as A, this one as B. We are going to draw a free body diagram for A. A is in contact with the surface. There is a normal force. Okay, there is this force on a string that pulls in this direction. It's a tension force. Then we have a frictional force is opposing the motion. Let's assume that this is going to the right system. So it's been a weight. So for object A, the free body diagram is like that. We have a normal force, we have F, we have the tension, we have a weight. Okay, let's look at this one. This one is pulled by tension and it also have a what? A frictional force. So there is a tension nalapha kuyo itsalela ngapha. Okay, then we have a normal force that acts perpendicular, then we have a weight. Okay, so for that one below, we have this force applied to this direction. Okay, force applied. Then we have a frictional force, and also in this direction we have a what? A tension. So we have the normal force and what? And the weight. This one is 5 marks. Okay, so this is the tension. All right, now this is very easy. When you calculate whatever, here you have two objects, which means you are going to have two equations. So you have an equation for A and equation for B. Let's start with A. Okay, for A, we have the horizontal forces. Friction is negative, therefore tension for A is positive. So the F net force is always equal to MA. Uyayibhala loo nto. So we have T minus F friction, which is equal to MA, because we said that the friction must be negative. We're done for A, you just substitute there. Okay, then for B we have this free body diagram. We done the free body diagram. Then the friction must be negative, which means this tension is negative, therefore this one is positive. Okay, note that. So which means the net force for B will be written like this one, MA. The net force for B will be a force that is applied minus T minus small letter f, which is equal to MA. Now, if you can look at tension ayifani ngokwe-signs, no negative apha sino positive. So that is Newton's third law of motion. This is Newton's third law of motion. These forces are equal in magnitude in the opposite direction. So into efuneka uyifake entloko is that tension ka-object A, i-sign yayo ayizufana ne-tension ka-object B. So in that case, you'll be safe. Okay, you'll be very, very safe. Once you draw a free body diagram, enye izoba positive tension, enye ibe negative. That is Newton's third law. Okay, so we are going to do a question on Newton's second law using all of what we said in this video on the next video. But now let's talk about Newton's second law and the definition. We are going to draw the graphs on Newton's second law now. Newton's second law. So Newton's second law states that the net force acts on an object. When the net force acts on an object, the object will accelerate in the direction of the net force, with acceleration that is directly proportional to the net force. The acceleration is directly proportional to the net force, but inversely proportional to the mass of an object. What does that mean? When the net force increases, the acceleration increases directly proportional. But when the mass increases, acceleration decreases inversely proportional. Now, masizobe graphs. So many graphs. So, net force, when the net force increases, when the net force, net force, meaning that net force is your x. Remember, we have xy as coordinates. So when the net force increases, the acceleration increases. Therefore, this one is an independent variable. Acceleration is a dependent variable. X, xy, this one is y, this one is y, mass is x. So I have F net here. I have what? Acceleration. When the net force increases, acceleration increases. This is the graph. Then you're done. Let's look at this graph. Acceleration, I said, is y. So in this case, mass is what? Is your x. Now, if you can look in this one, as mass increases, acceleration decreases. Now, what type of graph is this one? This one is hyperbola. Hyperbolic graph. Hyperbolic graph is y is equal to a over x. X is a numerator. That is hyperbolic graph. So izoma kanje, but this one is linear. Y is equal to mx plus c. Right? This is what your linear function. Okay, so if you can look here, you will get the gradient here. The gradient is calculated by change in y over change in x. On the y-axis I have acceleration, on the x-axis I have what? F net. Okay, let's look at this one. F net is equal to ma. Right? So if you want to do this one, you must divide by, let me first divide by a here. A. This cancels that. So I get this one. It's F net over what? Over A, not A over F net. Okay. So ithe ukuthi ke ngokulonda, since i-mass ilingana F net over A, therefore A over F net is inverse of M. It is an inverse of M. This is an inverse of M, of MS. It's 1 over M, not M exactly. So these are the graphs. I will also draw some graphs when we are doing the questions. Don't forget to write your question and also tell me the type of exam. November okanye ibe-trial okanye ibe-sub, so that ndikubalela question esiwakuwo. Don't forget to follow me on Facebook and also subscribe. Thank you. See you on the next video for the questions. Now we are going to apply everything that we said here on the next video on the questions. Thank you very much. Don't forget to subscribe. Right, we are going to do all the Newton's laws, but let's start with this one. This one is very difficult. Okay, remember, you draw a free body diagram, then you have another free body diagram for calculations. Choose direction. Thank you.